make a PDF drawing of your part that you can email to customers. That's it for today. Have fun.
That is regarding how to draw a detailed drawing of the component and how to modify in the drawing with the help of SolidWorks. Now, one assembly and detail drawings. About assembly and detail drawings, there are several different types of engineering drawings, as we have seen. Detailed drawings, that is single part drawing, assembly drawing, collective part drawing, combined drawing, combined detail and assembly drawing, and exploded drawing assemblies. This we have seen earlier. Now about detailed drawings, used as the main reference in the manufacture of the individual components, should give complete detailed information to manufacture the component, should completely define shape and size, it should include all the dimensions and tolerances, should include information related to material, treatment, surface finish, inspection required. Now one more simple assembly drawing. We will see how to draw or how to make a simple assembly drawing.
In this tutorial, I'm going to go through the creation of a simple assembly with two different parts as components and demonstrate how you can use two different types of common mates to put the parts together. So what I've already done in advance is I've created these two parts. This is the first part and this is the second part. These are in their own part documents in SolidWorks. I'm now going to go to one of my parts. I'll just start with this one, and I'm going to create an assembly based on it. So that can be done using this Make Assembly from Part Assembly icon here, or File, Make Assembly from Part. Either one will work. So when I do that, starting from one of the two documents, I'll get this Insert Component screen. And if you click on Graphics Preview here, you can see the part follow your mouse as you move out into the editing area. Usually for the insertion of the first part into the assembly, instead of manually placing it somewhere, I just click OK here to accept the default placement. So if I click OK, now we are in a new assembly document, and I see that the mate part 1 here is placed in the assembly as a component. One thing to notice is that it's got this F by it, meaning that it's fixed in place, and it has by default been fixed in its default location in the assembly. So that means that if I were to click out here and try to drag it around, it can't be moved. The selected component is fixed. Okay. So now it's time to add another component to the assembly. So I'm going to go to my Insert Components icon here. I can also go to Insert Component, Existing Part Assembly. And since both of these documents are open, they show up in this selector here. I could also browse to a file that is not open. But I'm going to go and select my mate part 2 here. And this time I don't want to select the default position because it's right on top of the first piece. So I'm just going to put my mouse cursor out into the editing area here and just click somewhere that's not on top of the other piece. It doesn't matter where. So now I can see that these two pieces are in the assembly. I can move the second one around freely, and it'll even go through the first one. I can't move the first one around because this one is fixed in place. See over here that mate part 2 has a hyphen in parentheses by it, meaning that it is not fixed and can be moved around. Okay, so let's say I want to mate this protrusion here to the groove over here. Such that this is kind of standing up at a 90-degree angle like this. The best way to do this is going to be with a set of 3 mates between coincident faces, and the best way to show that is just to go ahead and do it. So I start my mate mode by clicking on the paperclip here, mate here, and I'm going to click on pairs of faces that I want to be touching each other. So I'll start by clicking, I'll click this face here, and I want that to be touching this face. So the component moves into place, and I can click OK here, or this check button here. I'm going to temporarily leave mate mode just so that I can show what's happened here. So now when I drag this piece around, it's moving in such a way that this plane here and this plane here are coincident. So if I get a view like this, you'll notice that I cannot move the piece up and down. Okay. So I still have a lot of range of movement here, so I need to add 2 more mates to get this fully in place. So let's go back to our mate tool, and I'm now going to mate this face here with this inside face here. Okay. So now I can only move the piece like this. I can't move it this way, and I can't move it up and down. So the last pair of mates that I need to put in will be between here and here. Okay. Now notice that the hyphen in parentheses has gone away because mate part 2 is now fully defined in this assembly. It cannot be moved because it's got just enough mates to fully define its position in the assembly. So there's no more moving this around. Okay. All right, let's go ahead and add another piece. I'm going to actually, I think I want to add another copy of that mate part 2. So I'll go ahead and insert that here. Now notice that both of these are instances of this part called mate part 2. So if I were to go back and change that original part, they would both be updated in this assembly. They're not separate. Well, they're separate instances of the same object, but they're not separate objects. So this time, let's say I want to put this peg here and this hole here. I can do that using a concentric mate. So again, I'm going to open up the mate panel, and I'm going to click the outside cylindrical surface of the peg and the inside cylindrical surface of the hole. So let's see what that did. So now you can see that these inside and outside faces are lined up in a way that the pieces have to be right on top of each other in this way, and the freely moving piece that's not fixed in place can be rotated like this. I've also got this motion up and down because it's not taking into account the fact that the peg stops here. It's extending that cylindrical surface infinitely up and down. Same with the inside surface here. So I actually need one more mate to get that in place on the peg, and that'll be a mate between this face and this face. So we can do that. Here and here. So now the part is in place. It can't be moved off the peg because I've stuck these two faces together, but it still can be freely rotated. One last thing I want to show is that by default I can move objects through each other, which may not be what you want if you're trying to play around with something, how something behaves in reality. So one last thing that we can look at. Usually in an assembly, dragging things, just clicking and dragging will move things, but there's also an explicit move component tool here. So if I go in here and I click on collision detection and say stop at collision, now if I move things, it'll stop when it runs into something else and make a little beep on your computer. So now I can see exactly how this piece could move without going through other material. So that's a good way of investigating how your pieces interact with each other. And notice that it's highlighting the parts of the faces of the part that are crashing into each other. Let's just add one more mate here, or one more part. I'll insert the original part again, and we'll just mate this. Whoops. That edge isn't what I want, so I accidentally selected this edge, so I'm going to go back here and press the delete key to get rid of that in my selection. So I want this face and this face. Okay. Then I want this face and this face. And finally I want, say, this face and this face. Notice that I just mated these two faces together. They don't have to be touching. It's just that they're sharing the same plane. That's what the coincident faces means. One last thing that I should show, and we'll add one more part for this. I'm not going to fully mate this. I just want to show one thing. For every pair of coincident faces that are mated, there's actually two directions they could be mated in, and sometimes you need to flip them explicitly. So let's say I was going to mate this here with this face here. Okay. Now maybe this is what I intended, but I may have also intended for this to be the mate. So you can get there with this flip mate alignment button that's also available down here in the mate property manager. So that's something to keep in mind. If by default SolidWorks decides on the wrong orientation or the orientation that you hadn't intended, you may need to flip around the mate alignment this way. Let's get rid of this. I'm going to delete this component. Notice that these two, even though they're locked to each other and to the base component here, in a way that I could do this, they're not fully defined because they can still be moved somewhat, and that's fine in this case because I want to be able to do this rotating motion. So those are the coincident faces and concentric mate type.
So we have seen how to assemble the components with the help of solid edge, and how to draw, how to prepare the assembly of various components. Now one more detailed drawing which is shown over here with the help of third angle projection method. It is shown over here. The name of components are mentioned over here, that is, two holes are here. Newstone Engineering, it's a pipe bend. This is the bend which is used to connect two pipes, and here third angle projection method is used. Now let me see the references which would be helpful to you. So these are the references which is used to prepare this PPT, and through these websites you can get more details about the details and assembly drawing of the object. So I hope today's discussion would be fruitful to you. You might have learned how to draw detailed drawings, how to draw assembly drawing, where it is used in the industries, and how to use the fundamentals of details in assembly drawing to solve the particular problems. Thanks to all of you for being with me.